Welcome to Tech Talk. My name is Anna. I'm the host of this series. Today we're talking about hardware and test systems, and my guest for this episode is Charles Miquet. He is our lead global sales strategy manager at IPG Automotive. Welcome, Charles.
Hello, Anna. Good to have you here.
So today we are standing in front of one of our test systems, the steering in the loop. Charles, can you explain to us why this test system is relevant today?
Yes, so this steering in the loop test system can be used to validate and calibrate the steering system. And in the area of software-defined vehicles, so the steering is still a core component of the real car. So giving the driver the steering feeling, the safety feeling, but also feeling of the drivability of the vehicle. And therefore, it has to be calibrated and validated in the right way.
Let's talk about test applications. Can you give us some examples of what customers can test on this steering test bench?
Yeah, typically here you can test any driving situation where the steering is relevant, starting from fail-safe tests, but also functional tests and performance tests. You can use specific heuristics, an open and closed loop, also to characterize the steering behavior. Specific tests like on-center feeling or drift and pull behavior, but also standard ISO maneuver like the lane change or slaloms. And it's also possible to extend these test catalogs to ADAS and AV function, where steering also a main role like lane keeping assist, but also park assistance or highway pilot, and even driving situation using L4 and L5 AV stacks.
Can you maybe tell us more about the hardware in the loop method? What is the hardware here and what does in the loop mean?
Yes, here we have a front steering system as a unit on the test, and we want to have this front steering system behave in the same way than in a real car. And therefore we integrate this steering system in our virtual vehicle environment using the same mechanical interface. So on top, having the steering inputs and with a steer by angle or steer by torque. And here we have on a tie rod's hands, so the general force applied, resulting to the interaction of 3D rods, tire contact patch, tire model, but also axle design and suspension. And we are closing the loop using the steering rack position. We inject this position back to the virtual vehicle models so that the virtual vehicle behaves using this steering behavior. And in this way, you can conduct any virtual driving simulation directly on the test bed.
So this is how you make the device on a test believe that it is in an actual car. You already mentioned some components. Can you tell us about the main components in this test setup?
Yes, we have on top our servo motor. We use it to apply the steering inputs by means of steer by angle or steer by torque modes. We have here our linear actuators. This is the third generation we developed specifically for this application. They are specifically designed to reduce the moving mass so that we can guarantee the high dynamic and also high accuracy of the control. We can adapt the setup of the test bench to the geometry of the steering system using the same mounting points and having here our adjustable units for this. And here we have our hill setup with the XPEC4 real-time platform we use to generate all I/O signals and rest boost simulation like CAN, KNFD, Ethernet, FlexRay to integrate the unit on the test, the ECU. We offer also in these setups extensions like our driver in the loop system we can use to have a real driver here on the steering test bed, driving the steering system with a virtual vehicle. And we have also a dedicated unit here, the hands-off clutch we use for to emulate transition maneuver for ADAS AV stacks with hands-on transition setups.
To sum it up, can you maybe tell us about the key benefits of IPG Automotive steering in the loop test system?
Yes, so we are providing this test system on more than 10 years. You can use it to integrate and validate front steering system, but also steer-by-wire or rear axle steering system. You can use it in a really modular way and for 24/7 testing approach with high performance, high quality, and high dynamics. And it can be adapted also to any steering system architecture.
Charles, thank you so much for sharing your knowledge with us today. It was a pleasure having you here.
It was my pleasure. And if you have any further questions, just reach out. We'll be happy to talk with you.
This was our Tech Talk for today. See you next time.